Have you ever found yourself just sitting at your computer, staring at an AI chat window, and you're manually copying and pasting the exact same, like, multi-step prompt you used yesterday?
Oh, yeah. Like the massive bulleted checklist for reviewing a document or something.
Exactly. Or, a highly specific playbook for drafting your weekly report. And if you're doing that for, like, the third or fourth time this week, you are officially stuck in the manual prompting era.
Yeah, it is an incredibly common trap. We basically treat these super powerful AI models like hyper-competent assistants who unfortunately suffer from, total incurable amnesia every single time we open a new chat window.
Right. Every single time.
Yeah, and we spend half of our time just getting them back up to speed on how we like to work. It's exhausting.
It really is. And well, today's deep dive is all about how that specific era of repetitive setup is thankfully ending. We're exploring a massive architecture shift that took place in April 2026.
Anthropic's Claude skills.
Yes, Claude skills. We're going to analyze the official documentation, the architecture blueprints, and some really fascinating real-world case studies to understand this fundamental transition. We're looking at how AI is moving from being this fragile personal productivity tool that entirely relies on your prompting skills into like a formalized, compounding organizational asset.
Which is huge. And what's genuinely fascinating here is that this isn't just, another minor interface update or like a slightly larger context window.
Right, it's not just a tweak.
Exactly. It completely changes the fundamental nature of structured, repetitive work. And I want to be extremely clear right up front. While we will touch on some development concepts, this is not just for software engineers.
Definitely not.
This paradigm shift applies directly to anyone in any industry who manages complex, multi-step workflows.
Okay, so to understand why skills are such a monumental deal, I think we first need to look at the flaw in how most of us currently use AI. It really comes down to the context window problem, right?
Mhm.
And our absolute reliance on saved prompts.
Yeah, absolutely. Let's look at the mechanics of a prompt. When you use a manual prompt, the model has to guess two things simultaneously.
Okay, two things.
First, it has to parse your natural language to guess the specific task you want to accomplish. And second, it has to guess the process by which you want it accomplished based on, whatever context you manage to squeeze into that text box.
Which is a lot to ask.
It's a massive cognitive load for the model. It spends a ton of its processing hour just figuring out the rules of engagement, which leaves a huge margin for error. But with this skill, the process is already explicitly defined and just waiting there.
Okay, let's unpack this. If a prompt is essentially making the AI guess your intentions, what is a skill actually doing differently? Like, is it just a prompt saved somewhere else?
Not quite. According to the official architecture, skills are actual folders of instructions and resources that sit either in your local file system or in a shared company repository.
Oh, okay. Real folders.
Yeah, every skill lives in its own distinct directory, anchored by a mandatory markdown file called skill.md. To see why this matters, you have to look at what engineers call the memory trap.
The memory trap. Let's get into that.
Right, so up until now, power users have tried to solve the amnesia problem by relying on global system instructions, like a universal Claude.md file that tells the AI exactly who you are and how your company operates.
Right, the global instructions that just kind of sit in the background of your account. But wait, if I have a massive 50-point code review checklist sitting in the AI's global memory, and today I'm just asking it to help me draft a quick email.
That checklist is getting loaded into the background anyway.
Yeah, isn't that a problem?
Precisely. It is a massive waste of tokens and processing power. Everything in that global file gets loaded into every single conversation, just clogging up your active context window with totally irrelevant rules.
Which brings us to the underlying genius of skills, right? The thing Anthropic calls progressive discovery.
Yes, progressive discovery. So, these instruction folders, they sit completely dormant on your system. At the start of a session, Claude doesn't load the whole file. It only loads the names and a brief description of the available skills.
So it's basically just skimming a table of contents to see what tools are in the shed.
Exactly. That initial scan costs barely anything. We're talking about 30 to 50 tokens per skill.
Exactly.
The full markdown file with all those dense, heavy instructions is only injected into the active context window when it is semantically triggered by your specific request.
Oh, wow. So it pulls the knowledge only when the context actually demands it.
You got it.
So, okay, using a manual prompt is like having to explain your entire job to a brand new intern every single morning over coffee.
Right.
Whereas a skill is like handing that intern a laminated step-by-step standard operating procedure that they just keep in their desk drawer.
Oh, that's a brilliant way to put it.
Right. Like they don't read it every single day, but the second you say, hey, run the weekly audit, they pull it out and execute it flawlessly.
That is the perfect way to visualize it. You're designing a context that appears exactly when required, rather than forcing the AI to, carry the entire weight of your organizational knowledge at all times.
That sounds so much more efficient.
It really is. And Anthropic actually codified a heuristic for knowing when to make this transition. They call it the rule of three. If you find yourself manually pasting the same procedure, the same checklist or playbook into the chat for the third time.
You've officially outgrown the prompt.
Exactly. You need to stop typing and build a skill.
Okay, but handing the AI these laminated standard operating procedures, that raises a pretty major logistical question for me.
Sure, what is it?
Well, if the AI is scanning a bunch of dormant folders and deciding for itself when to trigger them, how do we stop it from grabbing the wrong instructions? Like, if I ask it to evaluate a new vendor, I don't want it accidentally triggering the employee offboarding skill just because they both involve, like, contract analysis.
Oh, absolutely. And this is exactly why the architecture of these files is so rigorous. Every master skill has to start with what is called YAML front matter.
YAML front matter.
Oh,
Okay.
yeah. Think of YAML front matter as the ID badge clipped to the front of that laminated procedure you mentioned. It has to follow strict formatting. First, you have the name of the skill. It is strictly capped at 64 lowercase characters, and this name actually becomes the / command you can use to manually trigger it.
Oh, like / evaluate vendor.
Exactly. But the most critical piece of real estate on that ID badge is the description field. This is your semantic trigger.
And I imagine you can't just write something super casual in there, right? Like, I shouldn't just type, hey, I want you to evaluate a vendor for me.
Yeah, if you write it like that, it is practically guaranteed that the system will ignore your skill.
Oh, really?
Yeah, the scanning nodes that perform that lightweight progressive discovery are incredibly literal. Rule 1, the description must be written in the third-person imperative.
Meaning what, exactly?
It should read, quote, evaluates new software vendors against company compliance, not I can help you evaluate vendors.
Ah, okay, that makes sense.
And rule 2, you have a strict 1024 character limit to describe exactly what the skill does and when the AI should apply it.
124 characters. That is not much space to explain a complex trigger.
It isn't. And crucially, you have to front-load the core scenario. The system physically truncates the description at 1536 characters to optimize scanning speed.
Wait, so it literally just stops reading?
Yes. If the core trigger word or scenario isn't sitting at the very beginning of that paragraph, the scanning node will blow right past it, and your skill will just sit dormant while the AI tries to guess its way through your task.
Okay, that makes total sense. You need to guarantee the semantic matching before anything else happens. But okay, once the skill actually triggers and the AI opens that folder, what do the actual instructions look like? Because the blueprints talk about something called a freedom slider.
Right, the freedom slider. It's a conceptual framework for how much leash you are giving the AI within the skill.md file. You're essentially dictating the tone of the execution. You have high freedom, medium freedom, and low freedom.
Okay, break those down for me.
So high freedom is basically an open field. This is perfect for something like an exploratory code review where multiple architectural approaches are valid, and you actually want the AI to suggest creative improvements.
Okay, what about medium and low?
Medium freedom introduces what developers call pseudocode. It basically means you are outlining a specific pattern you prefer, but variations are allowed.
Like drafting a report.
Exactly. Fantastic for generating monthly marketing reports where the structure is the same, but the narrative changes. Low freedom, however, is what the documentation calls the narrow bridge.
The narrow bridge. Sounds strict.
Very. These are exact scripts.
Yeah.
Strict, unyielding adherence to a sequence.
Wait, let me push back on that for a second. Aren't large language models famous for their lateral thinking and creativity? Like, the whole reason we use them is because they aren't rigid, old-school software. Why are we intentionally dialing down their freedom and treating them like a 1990s command line tool?
It's a great question, but if we zoom out and look at enterprise operations, creativity is often a massive liability in structured technical workflows.
A liability?
Yeah. Let's say you are running a legal compliance check on a new contract, or you're running a script to migrate a massive customer database. In those moments, you absolutely do not want the model getting creative with the parameters. One wrong move is fatal.
Oh, yeah, see your point.
Right. You are matching the rigidity of your instructions to the fragility of the task.
Okay, so if the task is highly fragile, like that database migration, and I'm building a low-freedom narrow bridge with hundreds of strict rules, what happens if I just dump all 500 rules into a single skill.md file? Does it just read it like a book?
No. And doing so leads directly into the first major anti-pattern you have to avoid, known as the monolith.
The monolith.
The monolith is exactly what it sounds like, a skill.mg file that is ballooned past 500 lines of text. The Anthropic documentation explicitly warns that crossing that 500-line threshold degrades the model's cognitive processing.
It just loses focus.
Exactly. It loses track of the primary goal. If your instructions are that long, you have to extract the heavy data, like reference tables or massive code snippets, into separate secondary files within the folder. You just keep the main skill.md file as a clean navigation menu.
But if we extract all those rules into separate files, wouldn't the AI get lost trying to follow the breadcrumb trail? Like if my main file tells it to go read document A and document A tells it to go read document B.
You've just identified the second anti-pattern, the Matryoshka.
Ah, like the nesting dolls.
Exactly. It's the nested references trap. If you create a chain of linked documents, Claude will almost always only read them partially. It might open document A, get halfway down, see a link to document B, jump over there, and completely forget the original instructions.
That sounds like me on Wikipedia.
Right. So to prevent this, you have to enforce the rule of one level. Every single reference document must be linked flatly and directly from the root skill.md file. No inception-style nesting allowed.
Okay, no nesting. And there's one more anti-pattern mentioned in the sources, the buffet, which to me sounds like giving AI too many options, like saying, hey, if you need to extract text from this PDF, you can use tool X, or maybe tool Y, or honestly tool Z if you feel like it.
Yes, exactly. Providing a buffet of options disorients the model. It spends precious compute cycles debating which tool to use instead of just doing the work. You want to provide one strict default path for the workflow, with exactly one escape hatch for edge cases.
Okay, so we've mapped out this perfectly structured logic layer. We know how to name it, we know how to trigger it, and we've avoided the anti-patterns. But logic without access to the real world is just theory, right?
Very true.
A perfectly written vendor evaluation skill is totally useless if the AI can't actually read the vendor contracts sitting in my email. So how do we connect these logic folders to a company's actual data?
Well, this is where we have to talk about the Model Context Protocol, or MCP. To understand the sheer scale of this protocol, by March 2026, MCP hit over 110 million monthly downloads.
110 million, that's huge.
It is. It has rapidly become the universal open standard for safely connecting AI models to external real-world systems, like databases, ticketing software, and cloud storage.
The sources have this really illuminating way of describing how MCP and skills work together. If MCP is the system that actually reaches into my database and pulls the numbers, what is the skill doing? Like, is MCP the chef in this scenario?
Actually, let's build on that professional kitchen metaphor the documentation uses.
Yeah.
MCP is the physical kitchen itself.
Okay, the kitchen.
It provides the infrastructure, the ovens, the prep stations, the raw ingredients from your database, and the sharp knives. It connects the AI to the physical reality of your company. But an AI standing in a fully stocked kitchen still doesn't know what to cook or how your restaurant plates its food.
Right.
The skills are the highly guarded recipe books. They provide the workflow knowledge and the technique.
I love that distinction. That makes a lot of sense. MCP gets the ingredients, the skill provides the technique. Let's look at a concrete example from the blueprints to see this in action. The sprint planning pipeline.
Oh, this is a great one.
Walk me through what happens when an engineering manager types /plan sprint into their chat.
The synergy here is incredible. First, the user triggers the skill. Immediately, the MCP server reaches out to the company's project management tool, let's say they use Linear. MCP pulls down the current unassigned backlog and the team's capacity for the week. But MCP itself doesn't know how your specific team prioritizes its work.
Right, because every company does velocity math completely differently.
Precisely. So the plan sprint skill steps in. It applies your internal team logic to those raw tickets. It applies your specific velocity math, your priority weights, and your custom tagging rules. It essentially organizes the chaos.
Amazing.
And then the model hands that beautifully structured sprint plan back to MCP, and MCP pushes those live, fully updated tickets directly back into Linear. The protocol retrieves the state, The skill dictates the reasoning, and the protocol executes the result.
But wait, juggling all of this takes serious processing power? If the AI is reading dozens of live tickets through MCP and keeping all these complex skill instructions in its head, won't its brain just kind of get full? The system architecture mentions that Claude retains a strict 25,000 token budget for all active skills combined in a given session.
It's a very real constraint.
Yeah.
But Anthropic built an elegant solution called the auto-compaction engine.
Auto-compaction.
Yeah, when your active context window starts filling up with data, the system doesn't just crash. Instead, it runs a compression strategy. It automatically drops the older, less relevant data, but it deliberately reattaches the most recent instructions from your skill to ensure the current task has context.
Oh, that's smart.
And crucially, it also preserves the very first 5,000 tokens of your session as a permanent anchor. So the AI never loses the original thread of what you asked it to do like an hour ago.
It's basically highly efficient short-term memory management.
Exactly.
But let's talk about the elephant in the room here, security.
Ah, yes.
If this AI has access to my actual company systems through MCP, and it's running these complex logic skills, how do we stop it from acting on its own? What stops it from accidentally deploying buggy code to production or sending a half-baked contract to a client just because the AI thinks the draft looks good?
It is the most important question an organization can ask. The architecture solves this with a framework called absolute invocation control.
Absolute invocation control.
It gives human operators a series of hard mechanical switches. First, you have the safety lock. In that YAML ID badge we discussed earlier, you can add a single line. Disable model invocation true.
So a physical kill switch.
Exactly. It completely blocks Claude from ever auto-triggering the skill on its own. The AI literally cannot run the procedure unless a human explicitly types the / command.
So for anything dangerous, like a deployment script or a financial transfer, you just lock it behind human intent. What about the opposite scenario, though? What if I have a folder full of background context, like a massive document explaining the weird quirks of our legacy software, that I actually want the AI to read automatically, but I don't want it cluttering up my / command menu?
Then you use the ghost protocol, which is tagged as user invocable false.
The ghost protocol sounds like a movie.
Yeah, it basically makes the skill invisible to the user's menu, operating entirely in the background as ambient knowledge that the AI can draw upon when needed. But the most targeted control mechanism is the use of glob patterns.
Wait, what exactly is a glob pattern?
Think of a glob pattern as a digital tripwire based on file locations. You can set a rule that says paths, src/ap/whatever.at.
Okay.
This means the AI will only auto-summon your strict back-end coding guidelines when a developer's cursor physically enters the specific folder where the back-end files live. The moment they leave that folder, the guidelines are dropped.
That's brilliant context switching. But what if the AI ignores the tripwire? What if it decides to execute a command anyway? Can we hard stop it before it permanently alters a file?
Absolutely. This was introduced in Claude Code 2.1 through the deterministic event loop. Instead of hoping the AI follows the rules, you can hard code pre-tool use and post-tool use hooks.
Okay.
A hook is essentially an unbypassable checkpoint. A pre-tool use hook can automatically inject a rigorous testing protocol right before the AI is allowed to save a new file. A post-tool use hook can automatically run a linting program to check for errors immediately after the file is saved.
It's just totally locked down.
Completely. It entirely eliminates the AI's ability to go rogue because the workflow state dictates the execution.
Okay, if you are listening right now and thinking, well, this is fascinating, but I work in marketing or HR, setting up back-end tripwires and deployment hooks really doesn't apply to my day-to-day life. According to the data in our sources, that is a massive misconception. We need to translate these developer terms into business reality.
Exactly. When we talk about executing code, we are really talking about structured technical workflows. This applies just as heavily to quality assurance, process engineering, compliance, and operations. Any role that relies on repeatable intellectual procedures is impacted.
The document workflows are the perfect example of this. How does a project manager or a marketer who doesn't know a single line of Python actually use this to, say, generate a complex financial report?
The user experience is incredibly simple. They just open their chat and type a / command, like /generate Q3 report. They don't need to write a prompt or explain the formatting.
They just type the command and that's it.
That's it. In the background, the skill actually writes and executes a real Python script to pull the data via MCP, process it, and generate a final downloadable binary file. We are seeing complex Excel files with formulas and pivot charts generated in about 2 minutes.
2 minutes.
Yeah, and a fully formatted PDF with extracted text, merged forms, and corporate branding takes about 40 to 60 seconds.
The enterprise ROI data on this is striking. The Anthropic blueprint highlights a marketing stack example. Marketing teams are taking their overarching context, which they call brand projects, loaded with core guidelines, and layering them with isolated procedure skills, like a brand voice skill and a content production skill.
And results.
Non-technical teams are seeing a 60 to 75% reduction in content production time.
That's insane, and you can see this shift in the adoption metrics. Look at the official Anthropic skills repository. The front-end design skill has over 110,000 weekly installs. Why? Because it enforces a bold aesthetic direction prior to writing any code, and it explicitly bans default fonts like Enter or Roboto. The user doesn't have to prompt the AI to, be creative with fonts. The context dictates it automatically.
That's so
The
brilliant.
document processing skills we just discussed are sitting at 94,600 installs. There's even an MCP builder skill where a non-technical user can guide Claude through a 4-phase process to build its own custom software integrations.
So if you work in compliance, instead of pasting a 20-page vendor policy into a chat window and generically asking the AI, does this contract look right, you just say /evaluate vendor, and the AI knows exactly what your specific company looks for step by step because the knowledge is embedded in the system, not in your personal prompt engineering ability.
This is exactly how team output reaches absolute consistency. By shifting the internal organizational conversation from how do we teach our employees to write better prompts to how do we globally design a better context, you eliminate human variability. You ensure a senior-level output regardless of who triggered the task.
Which leads us to the ultimate question. Where do these files actually live? How does an entire 500-person company share a /command?
Well, these skills don't just sit isolated on a local hard drive. They live in a version-controlled repository, usually a central .claude/skills directory, right alongside the company's core production code.
Wait, so they treated with the exact same reference as the actual software the company sells?
Precisely. They undergo rigorous review. Once approved, IT administrators distribute these shared skills to the wider organization. To the end user, they appear as view-only tools.
So nobody can accidentally mess them up.
Right. And if a senior manager updates the vendor evaluation criteria in the master file, it auto-updates silently for everyone in the organization instantly. It's a living, breathing, institutional operating system.
Think about the contrast for a junior employee. Traditionally, day one onboarding is terrible. You sit in a room, you read outdated wikis, and you spend 6 months bothering senior staff just to learn how the company actually operates.
It's the worst.
Under this new paradigm, on day one, that junior employee inherits the entire institutional knowledge of the team via their chat window. The skill library is basically an executable onboarding manual. It grants them instant capability.
And this causes a massive recalibration of roles for the senior staff. Senior engineers and team leads will spend significantly less time doing mechanical, repetitive document reviews. Their expertise is actively being codified into these exact markdown files. Moving forward, writing and refining skills is the new form of technical leadership.
So what we're essentially saying is that a company's true intellectual property isn't just their code base or their brand anymore. It's their custom library of markdown files that dictate exactly how they think and operate.
That is the core thesis. Intelligence no longer lives in the prompt. It lives in the architecture. Teams must design their context. The most efficient organizations in the future won't be the ones that hire the best AI prompters. They will be the ones with the most rigorously defined libraries of executable expertise.
It is a massive leap. We've seen how Claude skills are moving AI from a fragile, personal productivity hack, where you're constantly re-explaining yourself to an amnesiac assistant, into a compounding organizational asset. You connect it to the real world through MCP, package your team's best techniques into executable folders, and you unlock 60 to 75% time reductions in production workflows. It is staggering.
The transition from guessing processes to executing defined logic is complete.
But it does leave us with a pretty intense thought to mull over. If your company successfully extracts all the nuanced how-to knowledge from the brains of its senior leaders and codifies it into a flawless automated library of skills that literally any junior employee can execute with a simple slash command, what becomes the new defining value of a senior employee?
Yeah.
Do they just become middle managers of the AI's logic layer, maintaining the markdown files? Or is there a uniquely human element of intuition, an uncodifiable spark that a skill.md file can never ever replicate? Think about it. We'll catch you on the next deep dive.